This is AI7 Arcade Portable coming to you from a very messy bench today for a project that I've been waiting about a week on parts for. So if you've watched some of my recent videos, you'll see that I've got a new Starlink Mini. Starlink Mini is a pretty awesome little device. Allows you to have high-speed internet anywhere in the continental United States. It's pretty amazing. It runs on anything between 12 and 48 volts. Handles all of the switching over on the power supply itself. So long as you're feeding it something steady between 12 and 48 volts, it'll run it. I've been using the Starlink Mini off of my truck. It's been running great. But I want to be able to leave my truck. I want to be able to backpack it if I wanted to. I want to be able to bring it out to the tent away from the truck, do something like that without tying up any of my 12-volt batteries that I use for ham radio. So I have a whole bunch of these Ryobi 1 batteries. I'm a Ryobi geek. I have a whole bunch of these. I've been using Ryobi for the better part of 2 decades. So I've got them. I've got a whole bunch of them. And anybody who's bought a bunch of different tools, especially Ryobi, you will collect these pieces of junk, the slow chargers. So every time you buy a new tool that comes with a battery, they'll give you this thing. It is a very low wattage, slow charger for these Ryobi 1 batteries. I've got a 6-bay speed charger. I don't use these. I've got like 7 of them. I don't need them. So I'm going to use this and repurpose it as a power unit for my Starlink Mini. So instead of power coming in, power is going to go out. And I'm not using anything besides this and a couple little bits and bobs that I bought on Amazon. All right, so first things first, you got to use your little star hex to unscrew the bottom of this. All right, after you get the hex screws out, you've got the charging circuit board inside. You've got a little sensor lead that connects to the battery to let it know when it's plugged in to start charging, and I think it does some sort of pulse back and forth between the battery and the circuit board to talk with the BMS to see exactly when the battery's charged or something down those lines. We're not going to need any of that. I'm pulling that out. So inside here, this is what I'm talking about. Just a little Phillips screw holds that in place. We're going to go ahead and pull that out. All right, so we have separated the board. Now we're going to reuse this board, right? What I want, I don't need a lot of this. So I'm just using my flush cutters, cutting off a lot of this stuff just to get it out of the way. All the little, Jesus. All the little LEDs, all the little gobs of glue and all this crap. I'm going to cut all of this stuff off. Got some transistors and capacitors in here. Going to cut all that off. Pretty sure that is a regulator. So a real important thing to cut off here is this fuse. So this is on the positive side. If you follow the traces here, this big pad right here is where the positive on the battery is, and you'll see the schematic right there for the fuse across it. That fuse is what connects your positive of your battery to everything else on this board. So we're going to clip that fuse off. Clip the old power wires off of here. Now, I have gone on Amazon, and you can get essentially just a little adapter that you plug onto the top of this that leaves you 2 cables coming out. I wanted something a little bit cleaner, but I wanted something that as a standalone unit is just itself. And then I wanted something that will actually accept the Starlink cables rather than put everything together. So what I have left here is a board with all of the analog components taken off of it. And all that's left on here is all the surface mount stuff. And I don't care about any of that. So what I am going to be doing is you got your battery negative and your battery positive. On the back side, you'll see that the positive pad, that trace is an island, and that island was only bridged with that fuse that I clipped. Now the negative side, I shouldn't have to do anything different with that. It being grounded out to the board shouldn't do anything, but what I am going to do is I'm going to scrape off these traces and create this as an island as well, so it's not bridged to anything. And all I'm doing that with is a little flathead screwdriver that I have sharpened up for tiny little work. All I'm doing is scoring across so all I did there was scored across the trace, and now I'm going to try to break out that little bridge of trace right there. There we go. All right, so got the first one done. Now I'm going to do the exact same thing on the other trace that's jumping off that island. It's nothing fancy, nothing special, nothing pretty, but you see I scored across there and scored across there, and so now the negative side of that battery terminal is its own island, and it doesn't connect to any of the rest of this board. Realistically, it's probably unnecessary. The amperages that we're talking about and the voltages that we're talking about are low enough that it shouldn't be an issue. I don't have to worry about it jumping, and because all that would be connected is the negative side of the battery is not doing anything to that. Playing it safe, right? Okay, so the whole reason why I'm doing all of this is because I want these little guys here. I've gone on Amazon, I've seen the plugs that go on top, and really it's just folded wire, but I don't like how they're built. This was actually built by a Ryobi. It's built to fit all this stuff, so I'm just going to use it. So as far as the bits and bobs that I got, I had these, a bunch of inline fuses. So the Ryobi batteries, allegedly, on the 2 amp hour batteries, not the HP batteries, are supposed to run at 20 amps before the BMS starts to kind of freak out. On the HP batteries and the 4 amp hour and 6 amp hour, that number boosts up. Looking at the specs on the Starlink at 18 volts, should be pulling around 50 watts on max draw. So it'll pull like 10 watts, 10 to 15 watts on standby, 30 to 40 watts most of the time with peaks up to 50 watts. At 18 volts, that comes out to just shy of 3 amps. They recommend having a power supply capable of 100 watts to handle fluctuations, peaks, whatever. So even at that, now you're talking about 5.5 amps. So what I ended up doing is a 7.5 amp fuse, which is far below what the Ryobi batteries will handle, because I'm just trying to protect everything, right? So this fuse is going to be in there between the positive terminal and any of the rest of the circuit. I got a push button, locking button, not an intermittent button. When you push it, it stays clicked. It's also got a cool backlight little halo in there. And so that will all power off of that as well. I have the 2.1 millimeter 12 volt barrel connector. The spec sheets on the Starlink say it is a 2.5. It is in fact not a 2.5, it is a 2.1. The Starlink cable will fit snugly into a 2.1. It will not fit into the 2.5. So Elon, fix your manual. We got all the pieces that we need. It's not a lot to it. This is going to be the new internal circuit, a push button switch, a fuse, and the barrel connector that'll go out to the Starlink cable. So what we're going to be doing is we're going to be soldering this inline fuse. We're going to be soldering this directly to the board on the positive terminal side. What I have to figure out is how all of this stuff is going to fit in here, so I know how long I need to leave my terminals. So if it sits like that, I can get this inline fuse somewhere up out of the way. That works there. Positive side there. Perfect. I like that. All right, so we're going to do that. I'm going to solder this directly to the traces on the back here. So all I'm doing here is building up a big blob of solder between two of the pins on the terminal connector. All right, and there we go. Our positive is soldered directly onto the positive island. Got this little guy right here. So this push button switch here it's got three different wiring techniques that you can do on it. One is no backlight. One is the backlight stays on all the time, so you can find it in the dark. And the other is the backlight comes on when you want to turn it on. That's how I want it to be. I want it to be an indicator light. When the power is running, I want the light to be on. When the power is off, I want the light to be off. So I wired it up by the wiring diagram like this. So my double lead here is going to go right to the positive. This is going to go to my work, and this is going to get grounded to both. So this is going to be grounded to the board here. This is going to go to my load, which is going to be my Starlink, and then I'm going to have another tail coming off of this going to my Starlink. All right, so what I got to do now, I've got my power in. I know where my fuse is going to sit. Like so. I know this power's got to come out here somewhere, somehow. So that's going to come around like that. All right, so I got all that. That's good. Will the base sit on it when all this cable is like this? Yeah, that works. All right, is it pinching? Nope, sits nice. Good, all right. So we get that one taken care of. What I am going to want to do though, is I need to drill my holes for where I would like all of the stuff to come out. So I have a big hole in back already from where the power was going in. That's where I want the power to go out to the Starlink. I've got my 2.1 millimeter. I want that to go right in there. But as of right now, that hole is way too small. So let me get a drill bit to bore out that hole to this size. All I'm going to do here is put this clamshell back together, kind of pinch it, and is that big enough is the question. Not quite. All right, let me step that up. There we go. All right, so that fits. So I know where I want that to go. Get all plastic off me. So I'm going to have to hold this thing in with hot glue because this was designed to be the through case or through a panel. So I'm going to hot glue that back washer in place. So it'll fit nice and neat like that. Look at that. Doesn't that look sharp? All right. So I got my output. All I got to do is work on the rest of it. I'm going to have a lot of extra cable in here. So I think what I'm going to do is cut my inline fuse cable a little bit short, cut my output a little bit short, solder that, and do some heat shrink tubing on it to insulate everything and hold it together. So the negative is going to go right to the ground pad, right to the negative on the board. So this one can stay kind of long because it's going to have to wrap around. I cut this one a little bit short. I got to tin the end of that, and we'll get that soldered to here. I almost forgot. I got to figure out where I'm going to put my button because the button does have a little bit of depth to it. So that'll go there. My output is going there. I think a good place for the button, probably going to go on the other side. So let me get this in here. Let me get this drilled. And I'll show you guys what it looks like. All right, so I got a hole for my button. I got to put the little backer nut in there. So I'm going to fiddle around with that for a second and try to get it in there. I didn't think that was going to work, but that's going to work. I got to twist the whole head of the button to get this thing in there. Not a lot of space to work in there. There we go. Now we're cooking. Honestly, I might just be hot gluing that dang thing too. That is really snug, and I don't like farting around with all these wires on here. All right, while the glue gun heats up, I'm going to kind of mock up how all the rest of this is going to go. So I've got my output, which is going to go to the Starlink. I got my positive, which is going to come off of the fused end here. The fuse is going to go there. So this is going to connect to that. I have to have this positive, the double positive. So that is both the input. So this is off of the button, the double positive, that's off of the button. That is the light and the input to the button. Then I've got the negative off of the button, which is a bit long. I can probably clip that one short, or I'll leave it long. It'll be fine like that, I think. And then the negative off of the power output. That's all going to go there, kind of like that. And then this hold on. Ooh, yeah. See, this is why I'm mocking all of this up. My output, I was going the wrong direction, because that output is going off the button, not the battery. All right, so that will, hell, I could probably desolder that and solder this directly to that, so I'm not messing around with any junctions there. And then this one will go to that. All right, I like that better. All right, let me take all this apart. Okay, so this is all taking a little bit longer than it was supposed to, but that's how it goes. So tuck all that down in there. Get my output. The negative and negative are going to go to the board. And that positive right here, actually I'm going to clip some of that off because that's way too long too. I am almost here. Almost here. Damn it, I forgot the heat shrink again. This cold is getting to my brain. Don't be in a rush. Don't be in a rush. Take your time. Pay attention to what you're doing. Beautiful. All right. Now I put the heat shrink on. That is now a perfect length. Honestly, this washer in here, is more harm than help. I don't need this spring washer in here. It's not doing anything, so I'm just going to remove it. It's just getting in the way. And I'm going to end up hot gluing this anyways, so right now it's just in the way. There. Oh my goodness, that makes everything so much easier. All right. Got that in place. I got my output. The positive for my output is going down to the output of the button. I've got the buttons negative, and the buttons, the power for the LED and the power for the switch itself is right here. And then the output to the Starlink, its negative is right here. So now I'm ready to put the board on. I got everything all nice and dressed up. I got to put the board on and then start soldering in the board. So the first thing I'm going to do is my power output through the inline fuse block. I'm going to solder that wire first and then heat shrink it. Back to that. That's good all the way through. Good all the way through. Let's let it cool for a second. We'll get the shrink tubing pulled over the top of it. So I got my main power to the switch. It's going to flip like that. Let's get that sealed before we close everything up. Fold that up in there nice and neat. Awesome. All right. It's going to go there like that. Now, what I'm going to do is I'm going to put a little glob of hot glue just to hold this board into place. So that's kind of what they did. They used some sort of silicone when assembling this board for Ryobi. So I'm going to put a couple little globs in kind of some of the same spots here. And all that's going to do is hold this board in place and save my sanity a little. Hold that. All right, so before I lose working room, I'm also going to hot glue that push button switch in, and I'm going to hot glue my output in. And I'm just gooping the snot out of that. I'm just filling in all the gaps. I'm actually going to push some of that down around while it's still hot with my screwdriver here, filling all those gaps because I want that to be nice and snug and not come out. So I'm just, while the hot glue is hardening, I'm pushing on that button to keep it completely seated against the case until that hot glue gets cool and hardened. Now I'm going to do the, I think actually what I'm going to do is I'm going to put a little bit of hot glue on the thread to start, to keep this from backing out. I'm going to goop that all over the place in there. Oh, that's going to come back to bite me too because I still haven't got the other side. Yeah, crap. I got to pull all that off. I got to be able to put the other side on. If I put too much hot glue on there, it's not going to fit. It's not going to go on. So we're not going to do it that way. That'll be the last thing that we do. I've got plenty of room to work on it back there. Soldering everything to the board. So I'm going to shorten up that negative side a little. Good there. Oh yeah, okay, so I can't run through those holes there. Those holes are fine, none of that attaches there. Can I run on the side? Yep, all right, I got room on the side. So all these wires will come up the side. But those got to be free and clear. So that one will go like that. All right, so I'm gonna prep the board with some solder. All right, so I have these soldered onto the board here. So I got my negative side, I got my positive side. All that's nice. Now we got to test it a little bit. I got to put a battery on here. All right, so the moment of truth now. It's time to see if it blows up. All right, so apparently I got the wiring schematic wrong on the button because it's on all the time. Well, that's a booger move. I need to desolder. I need to pull the hot glue. That was such a dumb mistake. Okay, let me pull the battery off here. All right, I got a little bit of wiggle room here. Let me desolder this. I should have known better. As soon as I started looking at it and trying to scratch my head and figure out what I did wrong, I noticed if I have power output coming from the battery here, going through the fuse and going into the switch, but I only want this to come on when I push the button, why would the double line be directly on the fused output from the battery? No, the double line needs to be on whatever the load is, because when power is going to the load, power is also going to the light bulb. So I fixed it. It was a dumb mistake, but I fixed it. All right, so everything works. My outputs are good. Let's put it all back together and see if it runs the Starlink. Okay, so Starlink cable plugged into the back. Let's hope nothing blows up. The little blue light's on. Starlink lights blinking. Solid. That's it. That little package right there is internet anywhere in the world. All right, so I got her all hooked up. My Mini is online. All right, let's run a speed test on here. Oh, there we go. Look at that. All right, getting some good speeds there. Almost 200 meg. Yeah, look at that. On a Ryobi battery and something the size of a clipboard. It took me a little bit longer than I thought it was going to. It was about an hour and a half total of tear down, rebuild, and test. I'm happy with that though. On a 4 amp hour battery, should last me in between an hour and a half to 2 hours of kind of intermittent use. Roughly, if it's running full bore, I should be able to basically stream a movie on a single 4 amp hour Ryobi battery. If I bring a couple batteries with me, I could run it intermittently, send messages back and home to the family, tell the kids good night on Zoom or something like that for an entire weekend, a 4-day weekend. So I'm happy with this. It's not something I'm going to use all over the place. It's not something that I'm going to use all the time, but having this little Ryobi little thing to power my Starlink is a pretty cool backup. So this is AI7 Arcade Portable. Yeah, tinker a little bit. Man, you can go on Amazon, you can buy the little thing for the top and you can splice an adapter and you could do what I just did for under 50 bucks. I think I spent a total of 10 on the parts that I did. I used a charger that I already had that was just taking up space anyways. So yeah, I'm happy with what I did. You guys can take the easy way out. You can do it your way. I bet that you could probably source the parts that you need for less than 30 bucks. But hey, I like to tinker. So this is AI7 Arcade Portable. I'll see you guys on the bench next for working on that linked dipole and doing a permanent fix.